So first thing we have to do is prove that the motion is in simple harmonic motion, and they tell us how to do that. They say find x double dot. So in terms of x double dot, remember if it's in simple harmonic motion, it needs to end up in this form. And that is on your reference booklet, so you don't have to remember that. All right, so let's go. Let's do x dot first. So velocity is we get from differentiating with respect to t, the x equation. So here we go. So 3 cos t, so 2 of course disappears. 3 cos t becomes minus 3 sine t. Sine goes to cos, so 3 root 3 cos t. Okay, differentiating again with respect to t to get the acceleration. So sine goes to cos goes to minus sine. All right, so somehow that's got to be something to do with x. So let's have a look. If I put a minus 1 out the front, I've got 3 cos t. I've got the 3 root 3 sine t, which is pretty much what I want, but I also want a plus 2. So I'm going to plus 2 and minus 2 to balance that up. And then substitute the x in for all of that. Oops, all of that. Minus 2. So you can see that it is in that form. It's in this form up here, minus n squared x minus c. So therefore we can say the particle is in simple harmonic motion with, we can see from this that c gives us the center. So in ours we've got 2, so center is 2 centimeters. That's where the center is. And we can also get the period from this. So remember the period is 2 pi on n, and our n, if we compare it to that, our n is 1. So we're just getting a period of 2 pi on 1, which is 2 pi. And it's in seconds. All right, so it's definitely in simple harmonic motion. Okay, so the next thing we have to do is express 3 cos t. All right, I'm going to rub this out, or at least some of it. We might keep that bit. All right, so I hope that bit's okay. You can, uh-oh, didn't mean to do that. Okay. Oh, well. Okay, so if we have a look at 3 cos t and 3 root 3 sine t, we want to put it in the form a cos, I think they should have written t minus theta. So you can do it from memory, depends how you're taught. I like to just expand it and compare. So I'll put a cos t cos theta plus sine t sine theta. Okay, so we've got to figure out what that is. Now you can see that here cos t is there. So the bit that's not there, so the a cos theta has to equal, I'll just write it down here. So a cos theta has to equal 3, and the sine t is kind of in here. So the other bit, the a sine theta, has to equal 3 root 3. So if I put a sine theta on a cos theta, I'll end up with tan theta because the a's will cancel. 3 root 3 on 3, so that's root 3. Now we know that that is an angle of 60, so pi on 3, it wants the acute angle. So theta is pi on 3. We also know if we square both of them and add them together, so we've got a squared cos squared theta and a squared sine squared theta, so you can do this in your head. All right, gives us 3 squared plus 3 root 3 all squared. That's a 9 plus a 27, so that's 36. And if we factorize the left-hand side by a squared, we know sine squared plus cos squared equals 1. So we end up getting, I'll just do it over here, a squared, and you get the sine squared and the cos squared, which is 1, which is 36. Therefore, a must be 6. So if I go back up here, we know it's 6 cos t minus pi on 3 is what we get for that one. All right, so most of that I think you guys I don't know how you've learned it, but you can do it any way you like. Most of it we can do in our head there. So I'll get rid of this. Okay, so what does that tell us? So if I put it back to, what is the question? Hence state the amplitude and the initial phase, etc., etc. Okay, so let me go back to x. So x is, don't forget, it's 2 plus 3 cos t, 3 root 3 sine t, which is all this. So let's put 6 cos t minus pi on 3 in there. So, of course, it gives us our centre. So there's our centre. 2 is our centre. 6, of course, is our amplitude. I'll just write that there. So if we put those two together, our centre and our amplitude, so from 2, if I go down 6, I get to minus 4. From 2, if I go up 6, I get to 8. So it oscillates between minus 4 centimetres and 8 centimetres. This part here also gives you the initial phase. So the initial phase is negative pi on 3. So what is that? Let's have a look at what that looks like. So if I were to just, look at this. This is a cos curve. So if I just draw a cos curve at the moment without moving it, the centre we know is 2, and it goes up to 8 and down to minus 4. And the period is 2 pi because this coefficient of t here is 1. So here is 2 pi, here is pi. This bit would be pi on 2. All right, so it would be that curve, but remember this bit here is shifting it to the right, so it's pushing it along a bit by pi on 3. So if we do that, if I just kind of look at it backwards in a way, so if I go pi on 3 back this way, let's say that's pi on 3. So if I was kind of saying that's 0, then this would be minus pi on 3 there. But really what I want to do, so it's now starting from there instead of starting from here. So what you can do is actually put your y-axis in, or actually it's displacement, so that's x. And this is t, and then you can move everything along. So this then becomes, your time 0. All right, so you're just moving everything along by pi on 3. So this then becomes pi on 3, etc. So you can do it that way. Hope that helps.